Hi, in this video I'm going to be going through a few problems. Let's try to focus this here as I talk. A few problems dealing with simplifying expressions that have rational, it's fractional exponents. And I know we've already done this once, but I just feel like we need some more practice at it. So I'm just going to make sure I hit this again and explain a few rules. Here we go. First problem, 7 to the 1/4 times 7 to the 1/2. Okay, so you'll notice they both have the same base here. And when they both have the same base, that's fairly important. And when I say base, I mean the number that's being raised to a power. So the base is 7 in this case, and the exponent would be 1/4 and 1/2. And in this case, what it means is that I'm going to take, the rule is, I'm going to take the 1/4 and the 1/2, I'm going to add them together. And 1/4 plus 1/2 is 3/4. So that would simply give me 7 to the 3/4 power. Pretty simple, right? But here we have a problem where I go and I look at it and I'm like, well, wait a second, I don't have the same base here. I have a 4 raised to a power and a 3 raised to the power, and then whenever I get that all said and done, those are raised to the negative 1/5 power. And so really what we're trying to get across with this particular problem is the fact that whenever I have an exponent like this, I can go through and I can distribute out the negative 1/5 to both of the exponents on the inside. Remember, when I raise a power to a power, like this 3 to the 5th, if I were to raise that to the negative 1/5, powers raised to powers, that's when I multiply. I don't add, that's not 4 4/5. That's 5 times a negative 1/5. Well, it's a positive times a negative, which gives me a negative value, and 5 times 1/5 is just 1, okay? So that would be 3 to the negative 1 is what that piece becomes, okay? And then on the other side, I have 4 raised to the 5th, which is raised to the negative 1/5, and that ends up multiplying out to 5 in the negative 1/5, giving me a negative 1 as well, so that gives me 4 to the negative 1. So now this is really what I'm looking at. Now, it comes a matter of knowing what a negative exponent is. And remember, we can flip that to the bottom of a fraction and make it a positive exponent. And we can flip this to the bottom of the fraction and make it a positive exponent. And 1/4 times 1/3, you just multiply straight across. 1 times 1 on the top is 1, and 4 times 3 on the bottom is 12. It's 1/12. Now, I do want you to notice that I can go through for certain problems, like, see, this is a messy decimal, so I don't really have a good way to get an exact answer other than what I did. But on the second problem, where I get kind of a nice, neat number, in some situations, okay, so this is worth a shot on like an end-of-course exam or an ACT or something if that was a problem. See if I can get this where it's not going to be glaring too much, okay? What I can do is I can take 4 to the 5th, and I can multiply that times 3 to the 5th power, right? Actually, I would do it like this, 4 raised to the 5th times 3 raised to the 5th, okay? And I'm going to use parentheses to separate those out. Not that they're necessary, okay? If you really know your stuff here in order of operations, you'll understand that's kind of pointless to have those parentheses, but it's a good idea just to get in the habit of separating those things out with parentheses, because sometimes it will matter. So I have that number. That's the thing that's inside the parentheses. And if I raise that to the parentheses, notice, negative 1/5 power, I have to use parentheses in this case, I get this decimal, okay? And my calculator has the math fraction button. It's right here. I can hit math, and I can hit fraction, and I hit enter, and it's 1/12. So I can get the same number that way. Sometimes we get lucky, and that's possible. Sometimes we just, sorry, you got to do it the right way, okay? Over here, okay, this looks like an example that instead of multiplying two things with the same base together, I'm subtracting two things that have the same base. The base here is 5. Okay, so if I look at that, really remember, if there's nothing written there, it's really a 1, right? That's an important concept and probably one of the more missed concepts, as people assume that's a 0 if it's not written. No, it's 5 to the 1st power. If it was 5 to the 0, notice on my calculator I can type that in. 5 raised to the 0 power would be 1. In fact, anything raised to the 0 power is 1. Sorry about the glare from the light. I apologize about that. So if you have two values that have the same base and they're dividing, that is a subtraction problem. I'm going to take 1 minus 1/3 in this case, and that'd be 3/3 minus 1/3. That gives me 2/3, right? And so now I know that my answer would be 5 to the 2/3 power. It's that easy. Last problem. I go through here and I say, well, wait a second here. I have 42 to the 1/3 and 6 to the 1/3, and those are both squared. Like, how do I approach a problem like that? Well, honestly, if it's me, the first thing that I'm doing is I'm plugging into my calculator. So let's give that a shot first, okay? If we get a nice, neat number, then you know what? Let's not worry about it. 42 to the 1/3 is this guy, okay? Divided by, I'm going to use parentheses here, 6 raised to the 1/3, okay? Oh, I screwed that up. I need more parentheses. I need one set of parentheses to divide by the 6 to the power, and then another parentheses for the fraction there. So 2 sets of parentheses, okay? That's what the inside of those parentheses are. And I'm going to take this value, I'm going to square it, and hopefully I get a nice round number. And if we don't get a nice round number, then we need to find out, see, we got to have another way, right? Got to have another way. So here's what we do in this particular problem. 42, I might notice, is actually 6 times 7, right? And so really what I have is on the top, and this is where things get tricky. On the top, I have 6 times 7, that's 42, and that thing is raised to the 1/3 power. And this is 6 to the 1/3 power. And that whole thing is squared. That looks pretty disgusting, doesn't it, right? So here's an example of one that we really haven't attacked yet. Now, if I look at just the top, okay, so ignore everything else and look at just that piece, that's 2 things raised to the 1/3 power, right? And I can take the 1/3 and I can distribute it out to the 6 and the 7. So that would be then 6 to the 1/3 times 7 to the 1/3 on the top. I have a 6 to the 1/3 on bottom, and then that whole thing is squared. And now you might notice then, just lost my monitor, okay. Now you might notice one last piece here. See the 6 to the 1/3, you have one on top and bottom, and guess what? They go away. So I'm left with 7 to the 1/3. That thing is squared, so I have a power raised to a power, which means I multiply, and 1/3 times 2 is 2/3. This thing is 7 to the 2/3 power. Let's try it out and see. Remember how we did it the long way and we got 3.659? Okay, 7 raised to the parentheses 2/3 power is, we know we got the correct answer. Now, if this is on an end-of-course exam and you get a problem like that, I don't think you'll get something as complicated as this, but if you do, that's totally a guess and check problem in the end-of-course exam, isn't it? Where you go through and you compare decimals. You do it the long way like we did here up at the very beginning, and then you compare that to the answers that they give you and find out which one gives you 3.659, right? And if you're careful about parentheses, you should be okay with the guess and check on a multiple choice exam. Hopefully that makes sense. That's just a little refresher. Now it's your turn. You got 5 problems down at the bottom of the page to complete.